Everyone. My name is Cesar Gonzalez, and I will be chairing this session, number 7, together with my co-organizers, Patricia, Martin, Leticia, and Maria Elena, who are, all of them are present, I believe. This is session number 7 about vagueness in archaeology, and the issue is the main theme to deal with today is uncertainty, imprecision, and related things in the archaeological record. I want to thank our presenters today for their contributions. We have 90 minutes for the session, and 5 papers. So I suggest we do 15 minutes of presentation tops, plus 3 minutes for questions and comments. There is a Q&A system on the conference website that you can get to. So if you have any questions for the speakers, please type them there, and my colleague Patricia will be monitoring that so we can have a conversation. I don't want to take too much time, so I think we can go straight into our first contribution by Allard Mez, Data Mechanisms, Possibility and Limitations of Dealing with Time Intervals of the Roman Limes, Vagueness in the Case of Terra Sigillata Chronology. So Allard, the floor is yours.
Kalimera από το Mainz στη Germania. So my Greek isn't going very much further, so if I may continue in English, it would be fine. Actually, I'm doing this talk together with my colleague Florian Thierry. He works in the same department of scientific IT here at Mainz, which is a research foundation. So we have some time in doing research on fundamental issues in archaeology. So the online relational database, we call it Samian Research, contains approximately 250,000 finds of potter stems from all over Europe. They are basically from the Roman period, so starting with the Augustan period up to 260 AD. And this covered Europe with a thick layer of ceramics, which allows us to analyzing grids of trading patterns and so on of the Roman economy. But the problem we would like to talk about is the issue that traditionally in archaeology, fields are used like from and to. This stems from the old days of relational databases, but they are, I think, one of the biggest mistakes in archaeology that they exist at all. They suggest a sort of certainty which isn't there. And this quasi-certainty is derived from so-called dated sites. And one of these so-called dated sites, of series of dated sites, is this Hadrian's Wall in England, and there are also limes or defense installations in Germany. And these installations allow for comparisons and temporal reasoning between the Roman limes sections, because they are all consuming the same type of ceramics. The situation in Germany is far more complex than in Scotland, Hadrian's Wall, because Hadrian's Wall was more or less built in one instance. But the situation in Germany is that it is a gradual process of strings of military sites. And it makes it more complicated, but on the other hand, gives us much more dating or potential dating information about when these limes sections were built. But there is a lot of vagueness in there. We do not know really for sure where which one limes section was actually constructed. So the situation is that we have a limes section like Hadrian's Wall, which is constructed somewhere after 122 AD. It's the third consulate of Hadrian. We have another limes section where there are, for instance, dendrodates of 117, but the thing might have been constructed earlier. And there are other limes sections, like the mine limes, where we have actually not a clue as to where the starting and end dates are, likely in the same period, but we're not really sure. So these are floating between fixed points where the start of the reign of Hadrian is, for instance, one of the fixed points. And you can transpose this problem to other time interval things, like using C14 days in a prehistoric period. So we did have work done with the Exciton sticker on C14 days in the Congo, which then we thought were crocodiles there. We called the whole project and the program we use for analyzing this alligator program. Classically, Terra Sigillata or Samian is regarded as a dating instrument, and if you run off the mill dating curves of the Hadrian Wall castle military camps, you can see a quite consistent image that the datings aren't very diverging, so the pretty similar from the same, but there's always a sort of vagueness. But for instance, you can see a nice dip in the ascending curve, and this has probably a connection with the construction of another limes section, the Antonine Wall, somewhere around 165. So dating with Samian does give quite strong pointers, but isn't, say, a hardcore dating instrument like coins. And the problem is that many limes camps, military camps, are dated with Samian, and this causes the big threatening of circular reasonings in dating. And the material is then found on other civil sites, and the civil site is then indirectly dated by this limes section date. And I mentioned the issue of coin datings, where coin dating curves are a bit different. If you look at the coin series of the same limes section as the Samian dating curve. So there is something wrong or uncertain about this. The point with the coins is that you actually look at sort of loss curve. And coins are much, much longer in circulation than, for instance, Samian, which is a Roman tableware porcelain, which broke quite quickly. So how to deal with this problem? At first, we could use a correspondence analysis, the good old correspondence analysis, which does not take any dating information a priori. So the old adagium is the so-called horseshoe paradigm, where it suggests that a certain result pattern in the correspondence output may give a pointer that there is a chronology involved from early to late. As an example, as a provable example, you can take let's say the change of milk teeth to normal teeth with children. If you start with the baby mine period, then the percentage of milk teeth is 100%, and this slowly decreases up to the sixth calf, where virtually all children will have normal tooth. In a seriation on the left side, this is usually interpreted as a chronology being roughly visible on the horizontal x-axis. And this is also the case if you take such real chronological data. And if you run this as a correspondence analysis, you get indeed this pattern of a horseshoe. Where on the left side, the early one, the baby mine and kindergarten classes, and on the far right side, you have the later classes. So this looks quite okay as an assumption. If you apply this to more complicated situations, like time intervals of Roman emperors, reigning intervals, and even Roman emperors' consulates, then you get still a sort of chronological order on the first component of the correspondence analysis, but which may swap, for instance, the early complexes or time intervals or short-lived usurpators are in this case on the right side and the later ones on the left side, but the core idea is still roughly the same. That there is a sort of chronological order usually visible, but which may be caused by other factors. And that's of course why we use correspondence analysis. So our alligator tool creates a relative chronology derived from a correspondence analysis and can visualize it as a visual timeline. So what we actually try to do is what to do with the floating time intervals, such as the second consulate of Domitian, where we do not really know where it is, but it is somewhere sitting within the reign of Domitian. So you can then place time interval within other time intervals. But how exactly to do this? When we go back to the Limes example, we can try to look at the overlap between the Limes sections. So we use for this a low threshold accessible web tool, correspondence analysis we developed. So you just load up a CSV input file with the incidences, and you can then manipulate the data set to create a more stable data coherence. So give me, let's say, all the potters which occur at least 4 times on different sites, or sites must at least occur 2 or 4 times, whatever. So this is a accompanying tool we developed to make creating correspondence analysis output more easy. It doesn't say that you shouldn't study the idea of correspondence analysis. Of course, this is the dangerous aspect of such easy accessible tools. What we're working on together with Sophie Schmid is a more complete string of the procedure to generate all the required system files in R. This work hasn't been finished completely. But as an output, you can have, let's say, a correspondence analysis of the Limes sections and the potters, terrasigillata potters occurring in these Limes section. And there we see again a suggested chronology from left early and to the right late. But how exactly are these Limes sections then positioned towards each other? For this, we developed the so-called alligator method. So what we basically do is that we let the tool resolve the vague floating Limes parts. As an example, so Hadrian's Wall on North Sea coasts, which are a bit, especially the North Sea coast, not very well known and very well describable Limes section. We know the end date could be 260, but we do not really know. But we know, for instance, for the North Sea coast, we know the starting date. And for Hadrian's Wall, we are actually not really sure when it actually started. Somewhere in the reign of Hadrian's Wall. So these float, and the idea is that the alligator tool then places more precisely this Limes section between the others, where we have indeed fixed dates, like the Elisabethenstrasse, which started 74 AD and ended up in 104. And this then leads to the placement of these uncertain, or what we call virtual fuzzy start and end years of Limes parts. And we call these virtual timelines. The core idea behind this is that it is based on Allen's interval algorithm. There are 13 ways of describing relations between time intervals. So the time interval is before, after, or meets, and overlaps, and overlap by, and finish by, etc. So 13 different ways to annotate the time interval. And you can then, in this way, you can generate a matrix of the relations between the Limes sections involved. So basically you can define the relations also as a graph. Here you see an example in U4G where the information is said that the Hadrian Wall has started when Elisabethstrasse has finished, or one of these 13 categories. And each Limes section can be put in connection with each other Limes section. As a second step, we can then look at the real amount of overlap between these Limes sections simply by the quantification of the potters they have in common or not in common. And this we can express as the so-called Pearson correspondence analysis. And in this case, we have used a variant, a normalized Pearson correlation coefficient, so we don't have to calculate with minus values. But this gives you a sort of starting table of the amount of overlap. So the basic idea is then, for the reasoning, following the Allen interval algebra, that you can look at things like if Hadrian's Wall during the Wetterau Limes and the Wetterau is after the Elisabethstrasse, then the Elisabethstrasse should be before Hadrian's Wall. Yeah? So this is the core idea behind the Allen's algorithm, which we use to define the relations we find visualized in the correspondence analysis. So this is what we call roll chain axioms, and therefore we use the academic meta tool to calculate these inferred results. And this then, as an iteration example of this alligator method, the relative chronology towards other Limes parts is in this case, okay, if Hadrian Wall is existing during the Wetterau Limes and the Wetterau Limes is after the Elisabethstrasse, then we can calculate a value between Elisabethstrasse and Hadrian's Wall, which is in this case 0.5 something, which means virtually 0 in terms of normalized Pearson correlation coefficient. So there again, you have a tool to embed floating time intervals, creating this relative chronology according to the Allen's interval algebra. And what we do is applying temporal reasoning with the academic meta tool. And this is, so to say, on top of enhancement of correspondence analysis, which allows us to define the more historically the relation which is just plain visualized by a correspondence analysis, which is not really yet interpreted. As an archaeological result, we can say Samian is a dating tool, yes, and it can contribute to independent relative chronologies if one applies this vagueness modeling. But of course, it is. But this is the same thing as for coins. It is not an absolute dating tool. Yeah? So we always look at relative datable time intervals, and the material itself has a sort of fuzziness in its dating quality. And this is just sort of end goal of this project, to say, hey, you cannot really date precise with Samian. So say 40 to 65 AD, that is nonsense, but there is vagueness in this, and we can even now quantify this vagueness. Thank you.
Thank you very much. Thanks for your talk, Allard. You've run a bit over time, so we have really just 1 minute for questions. If there is a quick question, we can do it now, or if not, we can jump to the next contribution. Anybody? No? Okay. Well, in that case, thank you a lot. And let's move to our next paper by Piraye Hachigutsaya on the emergent supremacy of structured digital data in archaeology. You have 18-minute tops. Thank you.
Thank you very much. I will very quickly try to share my screen. Yeah, I don't know if it's working. Yeah, do you see the full screen?
Yes, it's fine.
Excellent. So I will try to be quick because this is also, big paper, big work. First of all, I would like to thank my co-authors who couldn't be here because of other commitments within CAA, James and Sarah. This is a mutual effort. So very quickly, so there can be little doubt that the digital transition, especially of the last 3 decades within archaeology, has had really far-reaching impacts upon the routine practices of representing archaeological information and in turn producing archaeological knowledge. And one such impact of this digital transition has been the generation of structured data in increasingly larger quantities, which has arguably resulted in ever-increasing dependence of archaeological knowledge production processes upon such data. So this emerging ubiquity of structured data, or cause some sort of a supremacy, we would like to say, and that proliferation has to do with few things, which I won't have time to elaborate in this short talk, but there is this new digital tools and know-how becoming available to archaeologists increasingly, of course, and high quality semi-structured or structured data sets are being increasingly taken as like primary reliable resources in archaeological knowledge production, and there is a push towards open data. And then simultaneously, though, there has been this theoretical turn within and beyond archaeology with this more than representational, non-anthropocentric discourses that's also within the last 2 decades. And it was also made it clear that scientific knowledge is produced via a skilled and messy process that involves complex interactions between people and their materials, the materials around them, and the representational resources. And the message in these, let's say, non-representational epistemologies has been that, let's say, non-representational theories has been that the epistemological agency of representations, so what representations does to knowledge, so it should not be downplayed that representations truly matter in the process of creating knowledge. So we observe that while this the epistemological affordances and varied impacts of different media on archaeological knowledge production have been scrutinized by many practitioners in recent decades for a variety of different representational media, sources of digital structured data like traditional relational databases, content management systems, online data infrastructures, and like Europeana, Ariadne Plus. But it's not that these projects are great. It's not about that, but they are they contain large amounts of structured data, and that there has been far less critical inquiry about that kind of representation, what it does to archaeology. Now, already back in 2012, Labrador writes that despite their importance and ubiquity, archaeological database systems are rarely the subject of theoretical analysis. And in fact, so he's there. We already see that they are saying that there we have to look more carefully into archaeological databases, and so much like the Cartesian map, in fact, which is often understood as very neutral and objective, although this got deconstructed in the last decade quite severely. Archaeological databases seem to have that kind of an image as well, that they are neutral, they are objective, and then we can unproblematically rely on them while creating our knowledge. There has been others in other disciplines like Nadine Skurman in geography who emphasize the same thing, saying that the vast majority of data users remain uncritical of data and unaware of their nuanced narratives. And for instance, according to Skurman, once data are placed in tables, their social lineage is forgotten. Yet such data and data structures are designed by people, reflect those people's ideologies and norms, and in turn help to shape others' values and overall conceptualizations of the world. So they are far from being neutral. And as Labrador also says, entering information into a database is an interpretative act. So this has been said almost 10 years ago, but there has been little done about it. So following a series of other practitioners, that some of which I just quoted, me and Sarah and James, let's say, we contend that while structured digital data may be lauded for their capacities to facilitate interoperability, equitable data exchange, democratic forms of engagement with, and widespread reuse of archaeological records, their constraints on archaeological knowledge formation processes are profound, and they deserve detailed interrogation. High quality sources of digital structured data are then representations like any other. So books, videos, TV shows about archaeology or an archaeological site, scientific reports, images, etc., and 3D models. And as such, they demand that we ask very important questions about, for instance, what by their very nature of their structure, they enable and resist, and specifically what structured data due to archaeological knowledge formation processes. And we can ask some additional question. So can all information, knowledge, and wisdom in archaeology be turned into structured data? And if so, what does this structuring cost us in terms of knowledge production and our knowledge understandings of the past? And if not, what is left behind if some forms of knowledge are left out of the equation? So these were the questions that we leaped from, let's say. Now, when we talk about structured data, of course, I don't have time here to give a very detailed description of what constitutes structured data, but let's say that when we talk about unstructured data, a typical type of unstructured data is text, because texts, although they are structured for humans that we can make sense of them, we can interpret them, for machines, the term structured here is about machines and machine readability, machine processing, so artificial intelligence in a way. So texts are as they are without markup, like with XML, etc. They are not structured for machines to be able to read them. So there is, of course, then an unavoidable friction appears between the data and structured data and the text. So one of the key legacies of the post-processualist movement in archaeology has been its emphasis upon interpretative archaeology, where archaeologists act as the interpreter of the past, the translator. So this positioning of the archaeologist as an agent for understanding of the past rests upon the notion that the past can be read like a text. So in post-processualist thinking, we see that there is a lot of emphasis put on texts. And then especially in Ian Hodder's particular brand of post-processual archaeology, we also see that there's a lot of emphasis on theory-ladenness of data, and also that the relationship between text and data is very peculiar in the sense that there you have more emphasis on text, and data is only something that's performed through human interpretation and text. So for instance, he says one cannot sit back and observe the data. They must be brought into action by asking questions. Why should anyone want to erect a building like that? What was the purpose of the shape of this ditch, etc.? So there, almost the text gets a more primary position than the data, where data is enacted through text. So although the theoretical discourse has moved on from these trends in recent years, the relationship between data and the various modes of publication that are rooted in that data still has, of course, massive relevance in archaeology. So that's now time then to ask if we are moving to a more structured data emphasized epistemological practices. It's then important to ask what happens to archaeological knowledge when texts play a minor role compared to structured data, since that's the trend we might be heading on at the moment. So it's for this reason that in this study that I will try to very quickly summarize in the I think 7-8 minutes that I hopefully, that we aim to map written extracts from a series of publication outputs from Çatalhöyük research project to see actually what is left behind and what cannot be structured in text, to see that what is actual, this shift towards structured data may be costing archaeological knowledge production processes. So our research was grounded in an analysis of 4 types of textual output from the Çatalhöyük project. So you can see in this slides, and then you have the primary data and the secondary data, the diaries, the gray literatures, and then formal academic publications and interpretative literature. So more or less, the schema shows that some more and more interpretative classification of the text produced on the basis of the data from Çatalhöyük. And then the interpretative literature can be sometimes hyper-interpretative to talk to the public on the, for instance, interpretative panels or mobile application storylines. And then this focus on the side of Çatalhöyük has 2 reasons, because we, 3 of us has worked long periods, especially Sarah and James in Çatalhöyük. In total, we worked 25 years on site, so we know the site as a team inside out. And also, of course, this very theoretical observation already existing within the Çatalhöyük research project about texts and data made the texts from Çatalhöyük quite interesting for us. So for the purpose of the study, as I said, we classified the data as you see in the slide. I just want to emphasize that that it goes from the bottom to top, as from least. I mean, that was the first initially we did. It's not that we want to dwell into that kind of thought very much, but that was initially we wanted to classify the text in that order. So our focus was like we wanted to map these texts to SciDoc and some of its extensions, like SciDoc, for instance, including CRM archaeology, and mapping, and I listed those on the right hand side. And what does mapping here refer? Mapping refers to the initially annotating words or phrases in these texts as correspond to CRM classes and properties. And we have used Recogito, a very user-friendly annotation platform for images and maps, very well known, images and texts, very well known in digital humanities communities. And then we try to annotate the text in a word by word or phrase by phrase level as it became clear. So this here you see a very clear, very short example of how the annotation worked. You can see that for each phrase or a word there, we found try to find a correspondence in the inside of CRM, a class or a property, and then you can see in red what cannot be annotated in this particular sentence. So the annotation process obviously has involved skilled and time-consuming labor, sometimes progressing with an average speed of 10 words per hour. Obviously, natural language processing was not possible here because this was a very complex process, and I don't think there is any algorithm at the moment suited for this purpose within natural language processing. Plus, there is no training data, so if anything, what we produce can serve as training data. So we, in total, annotated around 450 words from each type of text. So I have to emphasize that the results are quite preliminary because of the speed that the annotations had to go. But our data set is very high quality. And then a range of issues emerge, which are all very interesting in itself, but I have zero time to discuss here. So where the structured data fell down is like non-technical discourse, which is like things about remembering emotions, expectations, which showed up a lot, for instance, in archaeological diaries, spatiotemporal ambiguities or relational space. So anything which is not absolute space and not with coordinates was relatively difficult to annotate. Ontological ambiguity, which is like things that are difficult to describe, like what is life, what is being, what is presence, this kind of things were not possible to annotate. High-level archaeological interpretations that we saw in the interpretative panels for the visitors of the site, for instance, was very difficult to annotate. All of these boxes and non-similarity, so CRM structured data appear to function through similarity, and about uniqueness, otherness, that kind of thing was very difficult to annotate. And all of these boxes are actually deserve very detailed discussion, which I won't have time to do here. But so just a brief numbers about the prelim, about these results of like short text that we annotated. Only 53% of the annotations from the text of the mobile application was annotatable. And then the secondary data category that was difficult to annotate was the diary entries was almost as difficult to annotate, sort of, as the interpretative texts. So it was very striking then to see that actually the primary observations on site about which involved a lot of indeed the expectations, frustrations of archaeological, like the archaeologists on site, was very difficult to translate into structured data, and that was very striking. And then there was then the gray literature, and then the formal academic publications like the articles and then the monographs. You can see the percentages there. So the most one of the most striking results was that the diaries was almost as difficult to structure as the interpretative literature, let's say. I can skip this slide. So just to briefly conclude, we are not saying definitely that the structured data is not valid or valuable. Neither we are suggesting that its wide deployment isn't reasonable or useful. Quite the contrary, but they are almost always partial. So it's evident from analysis that most importantly, it is by which we structure structured data that causes this partiality. So we need to work on more on local and effective ontologies, let's say effective with an A, where you can include more of archaeological interpretation and emotions and effect that's going on, let's say, to give and local considerations of archaeological data that you have to incorporate in these ontologies like SciDoc-CRM. And obviously our study is also nothing against SciDoc-CRM. It's a great initiative, but we have to be aware that structured data, reliance on structured data this way has its consequences. And then the second is structured data is representations or as any other. So that means that we should not solely or give supremacy to structured data in archaeological knowledge representation, knowledge creation processes, but proliferate the types of representations. So we should give texts their place, images, and etc. We should work with various types of representations rather than focusing, relying too much on structured data. So the tension between the text and structured data was clear, and they are two different ways of representing archaeology again. And then, of course, there is some role here for natural language processing to make text machine readable, but they will end up with the same issues unless we address the source of the problem, which is the more inclusive ontologies, and also accepting that text structured data can only represent so much. And then, of course, it will be very interesting in the future, and this is my last slide, what about other representations like that would qualify as unstructured data, like images and moving images? If we try to annotate them and structure them with SciDoc or other ontologies, what is left behind? So we only address texts, but there are other types of unstructured data in archaeology. So that's for future research. And what are the implications of the content that cannot be annotated, structured there. So we would need to see that in the future as well. And of course, annotate more text to see how it is to move these results beyond preliminary. Thank you very much. I try to do my best to keep within the time limit.
Thank you, Piraye. Do we have a quick question? We have time for one quick question. No? Okay, I have a question myself. You began by saying that we rarely look at how databases affect or impact our work in archaeology, but have you engaged software engineers or usability engineers, people who create and develop database software, to discuss with them how databases impact our work?
Yeah, so that remark that I made was mostly about yeah, that's a good question. Yes, of course, they, if I understand your question well, they of course think about their data and software, but as people with domain knowledge in archaeology, I think we have to see how our data fits in the database. So it's, of course, there's an element of it at the software development stage, but I think this goes beyond the software development, and it's about the structure we give to our databases as we see fit our data. I hope it answers your question. So I think
okay, I understand.
Yeah, so I think there's an element of software development, but the issue is, I think, beyond that. It starts after, mostly.
Okay, thank you. Thank you.
Thank you very much.
Cesar, we have another question from the system. If you
very quickly, please.
Yes, it's very. How did you decide a text was not annotatable? Yeah.
Come again. Can you repeat the question, please?
Sorry. How did you decide a text was not annotatable?
How did we decide the text was not
yes,
annotatable?
if the text is annotatable or not?
Yeah,
it's from Rachel Opit. Yes.
Yeah.
Yes.
So so it's basically you have if we had time, I would explain that in detail. So in each case, you go to classes and properties descriptions of SciDoc to see whether there is any description that fits. And then in those cases, for instance, when someone says it was frustrating, for instance, in the diaries, it was frustrating to see that the collapse we are excavating is not yielding any information. There was something like that in the diaries. For instance, this kind of frustration, it's an emotion. And that there is no class that corresponds to that in SciDoc. I mean, there can be. I have to find the exact examples in there, but this is, I think, a more or less the way in which I think that it can be the shortest answer to that question, because there's not much time to answer it. So it's just basically, if you look at a sentence or a word or a phrase, and then you cannot find a description that corresponds to it, that would describe it in SciDoc, then the text, then that part is not annotatable.
Okay, I understand. Thank you.
Thank you very much.
Thank you, Piraye. Okay, let's move to our next paper. We have next Agnieszka Galishevska, The Ambiguity of the Classification Process in the Digital Environment, Typologies and Quantification of Shape Similarity in the Analysis of Pottery. So the floor is yours.
Thank you. I'm going to share my screen.
Definition and description. So, Danai, the floor is yours.
Thank you. One moment, please. Do you see my slides?
Yes.
Not the comments?
No, not the comments, just the slides.
Great. So thank you very much for organizing this session, and good morning from me as well. The title of this presentation is inspired by the Making of Types work of Adams and Adams in 1991. And the type formulation refers to any of the several processes by which we may arrive at the type concepts that are to be included in any typology. There are not inherently right or wrong type formulation methods, and usually practical typologies include types that are formulated in more than one way. The type definition refers to the fact that the type must possess a unique combination of attributes, present and absent, that distinguish it from all other types. And finally, the type description is not tantamount to definition and refers to the whole process of representation, where verbal and non-verbal methods may be involved. Although type descriptions are generally based on the morphological overlap and variations the certs exhibit between them, an inherent desired property of the traditional typological model is to arrive at the classification system of selected discrete categories. This usage of distinction over continuity in type characteristics and labels makes it convenient to attach meaning to the materials. But the hard boundaries rationale does not reflect the comparative nature and the fuzziness involved in the actual decision-making process of the typological arrangement. So in this presentation, we aim to bring back the richness of information and type membership in computer-aided typological arrangement applications And we will first get an overview of the Sagalas red sleepwear typological model, then discuss the shape quantification methods we reviewed, and we will continue with the grouping using soft boundaries and type description in rings and in full profiles. So the Sagalassos emerged in the late Archaeomenid period and had the continuous occupation until the Middle Byzantine period. And during Roman imperial times, a local form of tableware named the Sagalas red sleepwear was produced. Each Sagalassos red sleepwear can be given a label, like the one you see in the slide, 1A150, which consists of 4 parts. The first is the fabric the shirt is made from, and this part is not included in this work. Even if the fabric may be correlated to shirt morphology, we are only studying 3 parts of the label that directly capture the shirt morphology. The functionality is inferred based on the global shape characteristics. The type encodes the finer morphological characteristics of the diagnostic parts of the vessels, and the variant is the lower level of classification and describes the presence or absence of decoration, but it can also describe very fine differences in morphology. Following the taxonomic classification of arrangements, the Sagalassos red sleepwear typology is built as a descriptive arrangement and uses several of the grouping methods. Bounded grouping occurs by assigning extrinsic boundaries to the material understanding, such that the ones that result from specifying a locus or an assemblage. And attribute association refers to the discovery of the types that are popping up. But the SRSW typology is mainly based on the central tendency methods. Type varieties are used to group and present the material collection, and the technical drawings included in the collection exhibit the variation within each type. For each type, there is a statistical summary of geometric measures taken on the shirts. And for each type variant, the histogram and the corresponding tabular data are available. Here we see the geometric measures defined in the original typological model. And of course, type varieties and statistical summaries are accompanied by textual description, which serve as polythetic descriptors. The polythetic descriptors are shared between type variants, and by definition, they are not necessary or sufficient to attribute an item in the group. Here we see 2 word clouds for the textual descriptors of ball wall on the left and rims on the right. And now the thing is that the descriptors used in published typologies do not follow a defined standard. The description is dependent on the material at hand, and since there is no control vocabulary available, up to my knowledge at least, it is left to the material specialist. It is out of the scope of this paper to introduce a standard. However, we believe our methods in shape quantification and type description can contribute to the development of a standard. So to start with the analysis and the pottery quantification, we use technical drawings and we process them in R to retrieve the input for our algorithm. Since the drawings might contain gray values, the image is imported in RGB and thresholded. We also tried to automatically define the rim height, but we ended up defining it manually using a Shiny app and importing it as input as well. We implement information preserving methods for shape quantification, meaning that the original image can be fully reconstructed using the results of the quantification, and information non-preserving method tied to measurement-based typology building. Regarding the information preserving methods, the full profile is used, the coefficients of elliptic Fourier analysis, and the planar curves. Following the shape encoding method, we computed the distance between the shirts, and we actually tested several distance metrics, but we're not gonna go through them all here. Regarding now the geometric morphology, the geometric measures, we retrieve 35 variables, including the ones from the original typological model. And these variables are found in literature, like the one you see on the left part of the screen, or variables that we added ourselves specifically for capturing the shape of pottery after studying the polythetic descriptors and the images. So you see here some examples, like the rim inclination, the protuberance, and the flatness of the rim tip. And now, following the shape quantification and the distance computation, we embed the data in network using the STAD algorithm, which you see the reference in the bottom of the slide. And to choose the method we are going to use, we compare the mappings, the network mappings, by visually inspecting the derived structure and the links between the nodes that are the technical drawing images. As you see here, these are the rim images. In our case, we opt for the Cartesian representation as shape quantification method and the Manhattan distance metric, since we observed that this gave us the better results. And now, having a sensible mapping, we may proceed with the grouping, keeping in mind, of course, that grouping shards is an ill-posed problem. For the grouping, we first check for grouping structure using several algorithms like the elbow, the silhouette, and the affinity propagation algorithm. And in this case, we choose to make 4 clusters. The algorithm we use is the C-means, which is the fuzzy version of the known K-means clustering algorithm. And every shard has a degree of membership to all 4 clusters. The nodes are colored by the crisp class selected by the first of maximum method here. And the opacity is determined by the membership value in the cluster for these graphs. And the variations within the data can be summarized by superimposing the profiles per suggested cluster across the network embedding, as you see here in the bottom of the slide. We can now statistically test whether there is a set of attributes that contributes to the identification of the proposed types. We choose the random forest model here, and we highlight that the differences are mainly found in these 5 measures that are listed here. And we can also statistically test whether there is a set of extrinsic attributes or one extrinsic attribute that explains the difference between the algorithmically defined groups. The material specialist's hypothesis is that the difference in vessel size is meaningful for these subgroups. And we test this using ANOVA and the rim diameter as a proxy to measure size, because we didn't have the full profiles for all the shards. Therefore, we conclude, based on the ANOVA result, that the proposed subgroups vary in size indeed. The geometric measures, though now, however, do not have a one-to-one relationship with the textual descriptors that the material specialists are using. And therefore, we use fuzzy logic to combine measures and form rough rules to incorporate the uncertainties of the boundaries in the textual descriptions for the typological arrangement. Here we see the rule to define whether the rim is inverted or everted. And this rule involves 2 geometric measures in the premise and provides a degree of membership to each rim descriptor we aim to capture. The definition of the rules are based on the definition of measures and color brushing in the STAD network embedding for the unlabeled data. This is done by me, since there is no reference, let's say, in order to define this type of rules. And I'm not going to go through the other rules referring to rims. However, this method for characterizing shards is also applied to study multivocality in functional groups. The rules here are chosen based on the literature. So you see the inclination on the left, the height-width ratio in the middle, and on data means if the labels are known. Here we did not do any grouping. We took the labels of the material specialists, and we used the inclination, the height-width ratio, and the rim diameter means. And for this set of rules, we use 3 geometric measures, the ones that I just mentioned. And here we see an example using a profile originally labeled as a cup. And the result of the fuzzy inference system indicated that this is indeed most probably a cup. Here we see an example for a ball and an example for a dish, which is characterized 0.42 as a dish and 0.32 as a ball. By using this fuzzy inference system to characterize the search, we can retrieve textual descriptors that are richer in the description than a single measure. At the same time, they're closer to material specialist description and incorporate uncertainty in boundary definition. So to conclude, we propose the framework to conduct data-driven typological arrangement, retrieve algorithmic description, test hypotheses formulated by material specialists, test the consistency, and reveal gray areas, while maintaining the fuzziness involved in the decision-making of the material specialists at work. However, the generalization is difficult since there is no control vocabulary, as far as I know. Also, with this approach, we increase the complexity of attaching meaning to the material and make information propagation more difficult. Finally, adopting a fuzzy approach would radically change current standard techniques in archaeological applications. And in seriation, for example, algorithmic techniques should be enriched to account for probabilistic memberships to a type class. Thank you.
Thank you very much, Danai. Do we have any questions for Danai? No.
I have a question myself, Cesar.
Okay, sure, go ahead.
Yeah, hi Danai, thank you for the presentation. I just wonder, because you refer in several occasions that it's not control vocabulary about the shapes, and I just thinking about if you know if it is possible to include in this classification some kind of shape taxonomy or something like that you could use as help for this kind of polythetic descriptors or something like that. What do you think? What is your feeling about that?
I think that this is something, as an analyst, I would say, actually, as an analyst, I would say that this is something that the field needs, I think. If I were a material specialist, though, maybe I would not like to be restricted from some type of standard, maybe, or maybe
Yes.
the material at hand would not allow me to use that standard. And of course, I understand there is a lot of work to be done in order to achieve a taxonomy of shape. But I actually want to hear your opinion on that.
Me too. Thank you. Thank you.
Thank you.
Okay, thank you. Any other questions for Danai? Yes, Isa Romanovska has a question on the chat. A quick question to Danai about the 4 clusters detected. What did the ceramic specialists say? Did they confirm the groupings? Were there any surprises?
This clustering, the data that we used were of one type, actually. It was one type, 1B150, and this type was a type that the material specialist has already indicated that after 30 years, or how much is it, 20 years, that this typology is used, he sees some inconsistencies. So yeah, the proposed cluster was fine, but we didn't have any labels, let's say any ground truth or some prior classification to compare our results with. But yes, the material specialist said that it's sensible indeed.
Okay, thank you. All right, so let's move to our last paper today. This is by Mike Kelly, Reassessing Reflexive Digital Archaeology, a Modest Proposal. So Mike, the floor is yours.
Thanks, Cesar. How are we doing for time?
We have 11 minutes left, but I think it will be fine because we have a coffee break just after the session. So you have your 18 minutes as usual.
Okay, thanks. I'll see if I can share my screen. You seeing that?
Yes, yes, looks good.
Great. So today I'm going to talk about reflexivity in research and how that relates to uncertainty.
Excuse me, Mike. Sorry to interrupt. And now we are
Yeah.
seeing your full screen, not only the slide, but all the PowerPointy things.
Yeah, I want to be able to see my notes as well, so I'm not sure if I can. Let me just try again. I'll see if I can.
Now it looks better, yeah, but I don't know if that's fine for you.
Well, I can't see my notes, so that's a bit tricky.
Right, so feel free to use whatever mode.
Okay. Okay. What I'll do is I'll shift my notes onto my laptop, so if you just bear with me for one moment. So as I said, I'm going to talk today about reflexivity in research and how that relates to uncertainty, how it might inspire some principles for the design and use of software tools. It's quite a high level sort of theoretical paper. I don't have any results to report, but I do think it has practical implications, which I hope to go on to test in my research. So I'm going to skim through some of this because time is limited and it's quite a long presentation. So very briefly, this is some familiar territory, but when trying to understand how knowledge works, there has been a tendency to limit the available choices to these polar opposites of positivism and relativism. On the one hand, you've got an idea of an absolute truth about how the world is, independent of the person perceiving it, which scientific objectivism is slowly revealing to us. And then on the other hand, you've got the relativist idea, which comes out of the Romantic tradition, where imagination triumphs over science and each individual makes their own reality. And like others before me, I'm trying to find some fruitful ground between these two, suggest that it's a false binary choice. So we're looking at the territories in between. And I found, and I'm going to be mentioning them a bit in this presentation, I found stuff by Lakoff and Johnson's book, Metaphors We Live By. I found it a really useful book for making sense of the world, and it's very good at articulating what a third option between positivism and relativism might look like. So they call it experientialist synthesis. And underlying their arguments is the idea that all knowledge is related to individual experience. All meaning is meaning to a person. And they look at our uses of metaphor to make their case. So one example they give to explain this is the concept of a fake gun. And they use this to show that we conceptualize a gun in terms of a multi-dimensional gestalt of properties related to perception, motor activity, purpose, function, and so on. So the way we define concepts is not just related to the inherent properties of objects and experiences, but in terms of metaphors which emerge from our interactions with one another and with the world. And these in turn are geographically and culturally situated. So that's not to say that there are no truths, just that there's no absolute standpoint from which to obtain absolute objective truths about the world. It means only that the truth is relative to our conceptual system, which is grounded in our daily interactions with other people and with other agents in the environment that we live in. So to me, this is why reflexive practice is so useful and important, and because it recognizes that knowledge is situated and related to experience. And we've got Hodder, who's one of the key theorists and practitioners in this field, quoted here. So returning to archaeology, we've got Gavin Lucas saying that archaeology has evolved from a practice as a discipline trying to write a grand narrative of human history to one that's more concerned with the study of specific cultures and their practices and mutual influences. I think if we're saying that archaeology is a subject which is trying to understand historical cultures and their development, then logically it must be transparent, or it has to be transparent about the cultural perspectives that it's using to make sense of these. So we can think of context as providing a foundation for transparent research. And my suggestion is that what we tend to see, even with post-processual archaeology, is the tendency with digital research tools to focus on the internal coherence of a single situated perspective with little or no acknowledgement that it is situated. And these approaches can become confused with positivism. So we can consider that in relation to representations of uncertainty. Just a couple of examples I wanted to bring up. I thought the London Charter is very interesting. It's from 2006. It was a set of guidelines for practice which attempted to increase transparency and use of computer-based visualizations. And it came about due to growing awareness that these visualizations had the potential to be misleadingly authentic in their appearance. So in the section in the Charter on transparency requirements, there's a recognition that these might vary depending on the expectations of anticipated users and their level of knowledge and understanding. So in one way, we might interpret this as being derived from the influence of the situated knowledge approach, which takes context into account. And I'm guessing that the emergence of these principles was in part influenced by the work of contemporary theorists, such as Hodder. But an alternative reading of this is that it's written more from a perspective of a universal knowledge model, and it's just catering to different audiences with different levels of expertise. For example, academic specialists versus non-expert museum visitors. And this seems to be in the effective interpretation of the Charter made by various papers written around that time. And one paper, I just looked fairly randomly at, I did a lit review on this topic. So here's one fairly typical paper, which is by Kinkeldy and colleagues about how to assess visual communication of uncertainty. And it's concerned with the optimal visual metaphors for uncertainty. We're exploring which are the most intuitive and therefore the most effective. And in this kind of work, uncertainty is considered as a variable in a system. And the goal of the research is about making the system internally coherent and making representations effective. But there's little consideration of the context of the system or of the interactional properties, as Lakoff and Johnson would put it, or the cultural differences among potential audiences. So that's not to say that this work is not useful, rather that it's just that its presumed homogeneous academic audience is to some extent at least an idealized construct. And from a reflexive perspective, it needs to be understood as just one approach in a range of possible approaches. So thinking about maybe some of the more recent interesting work using ontological modeling to incorporate uncertainty. So these kind of papers are usually, again, focused on the attempt to make a universal model more coherent and complete, or at least more processable by computing means. But they don't always recognize the epistemological limits of universal models. So turning again to Lakoff and Johnson, they say that the set theoretical concept of a category doesn't really fit with the way that people categorize things and experiences in day-to-day life. For them, the metaphors that we use to make sense of complexity in the world are often inconsistent with each other because it's not easy to find a metaphor which will fit all use cases. So each metaphor gives a certain comprehension of one aspect of the concept and hides others. And to operate only in terms of a consistent set of metaphors is to hide many aspects of reality. So what we take from that is that categories and sets can exclude and obscure at the same time as they include and enlighten. So the truth of a statement is always relevant to the properties that are highlighted by the categories used in that statement, such as this one here. If you're talking about light consisting of waves, you're highlighting light's wave-like properties, but hiding its particle-like properties. And this is something I observed firsthand in interviews with archaeologists who were using a fixed set of categories to record landscape features. And they pointed out to me that research funding was actually less likely to be allocated to closer ground-based research, inspection of features which didn't fit into those established categories, even though sometimes those were the most intriguing looking areas. And we have other people doing work in this area. For example, Jiro's article on honouring ambiguity, which I found really useful. She talks about some techniques archaeologists use to deal with ambiguity and uncertainty, including what she calls cleaning the data and machining the data. And I think it's really useful to talk about these strategies in a constructive way in the framework that I've been discussing. And it helps us to avoid the extremes of the positivism, relativism debate that I mentioned before, and stops us from throwing out the baby with the bathwater. So we can see the value of attempts to rigorously achieve consistency within a data set to make entities comparable, for example. But at the same time, if we're to acknowledge the situated experiential nature of knowledge, we should, in the first instance, recognize that cleaning the data has the effect of obscuring some perspectives on it, and two, realize the limitations of relying on the inherent properties of entities to tell us something about the past. So the acceptance that knowledge is situated is the first plank of an approach that I've labeled epistemological modesty. So if we were to accept Lakoff and Johnson's conclusion that understanding is experiential and that we use mixed metaphors to make sense of the world, and these metaphors are not always mutually consistent, then we can see a barrier to the use of, for example, universal ontologies for the representation of archaeology. So if there are limitations to single perspectives and models, one principle could be that digital archaeology should be a social practice, as well as a technical or technological practice, as we need to consider as wide an array of evidence as possible. And therefore, software tools and platforms should be designed with that in mind. And I've been relying quite heavily on Lakoff and Johnson, but we can see similar conclusions being reached elsewhere. For example, in the pragmatic archaeological philosophy of Chapman and Wiley, which deals with this difficulty of charting the path between positivism and relativism by championing a stranded cable approach to building knowledge. That, in other words, making use of evidence from various different methods and different perspectives to build up a strong case for hypotheses. And similarly, we see other critics of an objectivist worldview calling for hybrid approaches. This is a quote from a familiar name I didn't realize would be on the same panel today. But the takeaway point is to use hybrid approaches and inclusiveness rather than dismissals based on totalizing accusations and exclusion of the other. So, is it possible to translate these rather philosophical ideas into software features? Well, the themes I've been discussing suggest that it is difficult potentially to achieve this using a self-contained piece of software. So software can have epistemologically modest features, as I've called them, such as the possibility to rewrite interpretations or to support parallel narratives, as well as the possibility to document context and process, commonly known as paradata in archaeology. But it's also likely that we do need to make use of digital networks or some kind of research ecosystem to support these activities and to build a self-critical awareness of context. So the best inspiration I've been able to find for something like this is actually GitHub, or something like GitHub, which is a website for sharing software projects. I would argue that there's a degree of epistemological modesty built into GitHub, which comes from a notion of built-in fallibility in software projects. So versioning is at the heart of the GitHub ecosystem because developers know that there are always bugs in software and there's always more to be done. So change and iteration is embraced first and foremost. And also software development is a bit like painting the Forth Road Bridge because the world changes around it. But the same thing happens to research ideas. So they should also be set up to handle change and iteration. Then you have forkability. That's the option to create a copy or a fork of a project and customize it. So you have multiple perspectives on the same project. And some of these will converge and collaborate in the long term. Others will run in parallel or diverge. So GitHub's success is not just as a repository store, its success comes from the social collaborative features of the Git versioning system, which in turn are enhanced by the social interaction and co-creation tools on the site. So it's like a working social hub, a bit like a beehive. And I'm really interested in whether this kind of cooperative model can translate to academic research. Then I've also mentioned electronic lab notebooks there. These have become a feature of science research publishing as a reaction to a crisis in the reproducibility of experimental outcomes. And again, they're used to document process and provide context. And for me, such initiatives shouldn't be limited to the sciences and to lab experiments. And I think this reproducibility movement is going to spread from the lab sciences into other disciplines. So yeah, this is the point where I make my pitch, or I would do if I had something to sell, but it's actually some open source software that I'm developing as part of my research, as an attempt to realize some of the ideas that I've been discussing. So the software is called Orson, which is roughly derived from Open Research Notebook. And you can find some documentation on the website listed there. So it's a Markdown-based digital research notebook. It tries to present its content in a way which provides context and encourages reusability and parallel interpretations. And it does that by retaining the building blocks of a research proposal and allowing them to be reconfigured in different ways. So the idea is that you have chunks of content, a bit like index cards in a filing system, which can be visualized in different ways or compiled into a final research narrative. So another goal is to make the content in Orson shareable and reusable by others so that it supports that social vision of digital research that I've been discussing. So I'm really, really keen for archaeologists to look at this software and give me guidance on the feature set in it, or even better, to test it on a live project. So if you're interested in trying it out, please do get in touch. It could be a good opportunity to have a web resource created for your project, perhaps. So just finishing up, there is likely to be a lot of pushback and challenges for this kind of epistemological modesty approach to, for example, building up authority status as a researcher, even for clearly identifying authorship in iterated research, if you're following that kind of collaborative GitHub model. There's also potential discomfort for acknowledging alternative perspectives or for showing your workings in a research notebook. We also might say that the strengths of computing is about creating coherent environments out of zeros and ones with hard Boolean edges. And that is largely the appeal of computers, the prospect of creating knowable, predictable, complete environments. So this approach may be in some ways a challenge to that. And then you have, if you're going to have an ecosystem of competing and complementary research models, that does require infrastructure and social investment. And it's useful looking at Gallison's work on trading zones. And he emphasizes in his writing, that time, money and effort were put into creating collaborative spaces for people who are working in an interdisciplinary way. So on the plus side, I think archaeology can make a really distinctive contribution in this area because it straddles the sciences and the humanities, and because it has a history of negotiating uncertainty. You might see it as being similar to sociology or anthropology in some ways, but with one hand tied behind its back and a blindfold on. So archaeology is often preoccupied with the effort of trying to see clearly and move freely. And I think this is where it can make a distinctive contribution to other disciplines by explaining how it overcomes lack of clarity and uncertainty. So finally, I just want to thank you for your attention, but also record my grateful thanks to the funding for this research, which has come from the CHA David Arnold Memorial Studentship. Okay, thank you.
Thank you, Mike. Thank you, everyone. Do you have any questions for Mike? No? Okay. We have still a few minutes before the coffee break finishes, so you're welcome to stay and ask any other speakers of the session, or leave as the next session is starting in a few minutes. In any case, thank you very much for attending the session. I think the 5 papers have been extremely interesting, and let's keep interacting throughout the conference. Thank you.
Cesar, we have a question for Mike. Sorry, it's
sure. Yes, go ahead.
The question and answering system is a little bit, you have some lag. So from James Zimmer Dauphine, hello, Mike. What do you think of software such as Google Docs for this sort of collaborative notebook setting?
Hi there. Yeah, I think Google Docs is great in some respects in that it incorporates that kind of versioning system that I mentioned. The difficulty with it is it's not great at handling specialized data outputs, so representing particular kinds of knowledge or some multimedia things. But it does tick a lot of boxes in that it provides a social collaborative space with versioning, and has that sort of capability for rewriting and augmenting the work of others. So yeah, some of the principles I think we can take from there are really useful, but for archaeology, it's great to be able to support different types of data and different types of visualization and interaction as well.
Thank you. Do we have any final questions for our speakers? No? Okay, well, thank you everyone for coming, and let's have some coffee that we deserve. Goodbye and see you around.
Thank you very much.
Thank
Bye.
you. Thank you all. Goodbye.
Thank
Thanks.
you. Goodbye.